And welcome back to another Recon podcast with Mr. Hagan. And on this podcast, we're going to continue looking at the production possibilities model. And we left off with the last podcast. We derived this marginal cost curve, and we derived this marginal cost curve from the production possibilities curve. And we derived the production possibilities curve from this data on the production possibilities schedule. So we graphed the data on guns and butter, and then we calculated the marginal cost for butter, and then we came over here to the production possibilities curve and we graphed all of that. So this blue line is that production possibilities curve that gives us all the combinations of guns and butter that are possible. And then we started up here at this point of 7 guns and 0 butter. We said if we start there and we want to add one more unit of butter, then we would have to give up some guns in the process. We would have to give up some guns as we shift some of our productive efforts to producing butter. So in this case, we were at 7 guns and 0 butter, and we added 1 unit of butter. We added 1 unit of butter to our production, and the time that we spent producing that butter, we had to give up some guns, and so then we had to move down back onto the production possibilities curve. And then if we added a second unit of butter, then we added a second unit of butter, and that's adding 1 unit to get from 1 unit of butter production to 2 units of butter production. When we add 1 unit of butter production, we had to give up 0.6 guns. We had to give up some guns again to get back to the production possibilities curve. And I just want to highlight that this idea is this idea of marginal cost is really the idea of slope. And why is that? This marginal cost idea is really kind of the slope of the production possibilities curve. Why? Well, what is slope? Slope is the change. It's the rise over the run. It's the change in the variable on the vertical axis divided by the change of the variable on the horizontal axis. Well, so it's the change in y over change in x. And in our example, the y variable up here on the vertical axis, the y variable is guns, so it's the change in g divided by the change in the horizontal axis, which in our example is butter, over the change in b for butter. So let's just say that we were right here at 6.8 guns and 1 butter, and we add 1 unit of butter. So my change in butter was 1. And then my change in guns, we gave up 0.6 guns. My change in guns would be 0.6. So there is the marginal cost. The marginal cost is the slope. The marginal cost is the slope because this is just 0.6. Okay? So the slope of the production possibilities curve is essentially the slope. The slope of the production possibilities curve, is essentially the marginal cost curve, which we then graphed over here. Okay? So really what we're graphing here, this is the slope of this. It's the slope of the production possibilities curve, except we're ignoring the negatives. This really is a negative 0.6, and we're ignoring that because we're using the word cost. Cost implies the negativity. Now, here I have a marginal cost curve. I want to ultimately answer this question: how many guns and how many butter will maximize happiness for Robinson Crusoe? And to do that, we needed the marginal cost curve, because we know that people engage in behavior up to the point that the marginal benefit equals the marginal cost. We know that from a previous video. So now we just need a marginal benefit curve. All right, so where's the marginal benefit curve? Well, we don't know exactly where the marginal benefit curve is, but Robinson Crusoe does. What we do know is that the marginal benefit curve slopes down because of diminishing marginal utility. So the marginal benefit curve might look something like this. We know it's a downward sloping curve. So let's just pretend that this is his marginal benefit curve for butter. So then, how many butters will he buy or produce? Well, for the first unit of butter, the marginal benefits are greater than the marginal cost, so he does it. Second butter, marginal benefits are greater than the marginal cost, so he does it. Third butter, marginal benefits equal the marginal cost. That's right here at butter number 3. So that's the number of units of butter that will maximize his utility, where the marginal benefit equals the marginal cost. And so I want to bring that back over here to the production possibilities curve. Right? 3 butters will maximize his utility. And if he produces 3 butter, well, now we got to go up to the production possibilities curve. If he can produce 3 butter, then he can produce 5 guns. So this point right here, 3 butter and 5 guns, that's the point of utility maximization, or what in economics we're going to call the point of allocative efficiency. Allocative efficiency. Allocative efficiency is the point where the marginal benefits equal to marginal cost. This is the point of utility maximization. How did I get there? I got there by finding the number of units of butter where the marginal benefits equal the marginal cost, maximize the utility in terms of butter production, and then I came back to the production possibilities curve and found that if we produce 3 butter, we could produce 5 guns. That's how I got the point allocative efficiency. That's the point. 5 guns and 3 butter that will maximize Robinson Crusoe's utility. So the answer is, what point is utility maximizing? What coordinate pair? It would be this. 3 butter and 5 guns is the point of utility maximization. Now, one thing to add to this, and that is the idea of productive efficiency. The idea of productive efficiency. So we just talked about allocative efficiency. Allocative efficiency is the point of utility maximization, where marginal benefit equals marginal cost. Productive efficiency just says to produce somewhere on the graph, to not be inefficient. So productive efficiency says produce on the graph, not inside it. That's inefficient. Produce somewhere on the graph. That's productively efficient. And then allocative efficiency tells you the exact point on the graph where the marginal benefit equals the marginal cost, where you will maximize utility. And so Robinson Crusoe will maximize utility at 3 butter and 5 guns, given that this is his marginal benefit curve. Given that that's his marginal benefit curve. We'll talk more about this on the next podcast. Thanks for joining me. This has been Mr. Hagan. We will see you on the next podcast.